Welcome, everyone. It's nice to be back on this conference. Today, a little provocative title, Your Tests Are Mocking You. It's a talk a little bit in defense of mocks. Like any other tool in our profession, it's often misused, it's often hated on, and I thought it's good to remind ourselves why we have those mocking frameworks and how to use them. My name is Jakub Zalas, or you can call me Kuba, which is short for Jakub. Find me on the social media. I'm a software developer for hire, do all kinds of various things. I used to be a Symfony core team member, so I have quite a lot of experience with PHP, but I do other tech as well. In my free time, I work on open source, drink beer, play guitar, and ride the bike. I'm a big fan of test-driven development. Everything I do is with test-driven development, but I won't be mentioning it too much today, even though we are talking about tools that are used with or associated with test-driven development. So we go through a quick introduction of what mocks or test doubles are. We'll take a little detour into talking about behavior and its verification of behavior, because that's important in the context of mocks. Talk about the chain premise, what it is, and then two important ingredients to be used with mocks, collaboration and contract tests. We'll end up with some mocking hell, some examples randomly found on GitHub. We'll discuss how people used mocks and maybe how could they improve their usage. So quickly, what are mocks? Mocks technically should be called test doubles, but I guess that name didn't really catch on because it's easier to say I'm going to mock this, I'm going to mock that, than use the word test double. Test doubles were first documented in the book by Gerard Meszaros, X-Unit Test Patterns. It's a great book. Can be boring to read, but I think it's very important because it has most of the patterns you will ever need in it. And it describes those patterns without judgment. So it doesn't say this pattern is good or not, that it shows it in the context, so you know when to apply a given pattern. So test doubles were defined there, and as you see, there's many variations of test doubles. We'll talk about them today as well. So why do we need them? Imagine you have a test that is supposed to exercise a bit of behavior. We call it system under test. That can be anything. That can be a method, that can be a function, that could be a cluster of objects. Doesn't matter, something we want to test. That thing has a dependency on another thing, as they often do. That other thing might also call the database or make an API call somewhere, read something from the file system, doesn't matter. So in our test, we want to avoid all those side effects. We want to make the test reliable, predictable. Every time we run it, we should get the same outcome. So we kind of want to detach from that dependency. That's where test doubles come in. We replace that dependency with something that's easier to control. That might be for various reasons. One of the reasons might be that the dependency is hard to control. Either we can't control the input that it's supposed to get, or we can't control the output that the dependency produces, or we can't verify that output easily. It might be that if we're working outside in test-driven development, that dependency doesn't even exist yet. But we want to write the test on the higher level. Or it might be that the dependency causes our tests to be slow because it talks to a database. And we have hundreds of those tests on our system under test, and that database just slows things down. So various reasons to use them. Important thing here is that we are not replacing objects, we're not replacing objects as data or as entities. We are replacing behaviors. So we're replacing that behavior that fetches us latest blog posts, for example. Or we are replacing that behavior that publishes those blog posts. Yeah? We're not replacing the blog post dependency. We replace, or the repository. We're replacing the behavior that the repository provides. So that's why I wanted to take a little detour and talk about behaviors, what they are, and how we can actually verify them in our tests. So behavior is a reaction to input as an output. So input plus output, that's the behavior. So circle goes in, square goes out. Circle, that's input, square, output. Behavior produces output based on the input. And both input and output can be direct or indirect. Direct input is something that we receive as arguments to our method or a function. Direct output is its returned value. But those inputs and outputs are not always direct, as we'll learn. It's a bit of delay. So quickly, how we can verify such behaviors. The simplest function we can think of is one that just takes the input, calculates the result, and returns it. That's a called pure function, so that means it has no side effects. It doesn't talk to any file system, it doesn't talk to a database, or doesn't throw exceptions. It doesn't matter if it rains, if the sun is shining. Whenever I put 25 into this function, it will always return 77. Yeah. So that's the best test we can hope for, because it follows the standard pattern. Given the input, when we invoke the action, then we expect some output. Given when then, arrange, act, assert, no side effects. A variation of this might be a behavior that not only takes input from its arguments, but also has some state associated with it. It could be a state within an object, it could be state encapsulated by a function, but that state is immutable, so it's only an input. So notice that's kind of an additional input to your behavior, to your function. We tested quite similarly to the previous case. Arrange the input, invoke the behavior, verify the output. Yeah? Except that our state is immutable, so we have to create a new instance as a result. Yeah? So-called value objects. Then, next to reading the state, we can also write the state. So the output now not only may be a result of the function, but also an updated state internally. So on its own, in isolation, it's not that harder to test. We need to change our practice a bit. Now we construct the object, pass the input, so the initial state, invoke the behavior, but there might be no return value. Now the outcome is result of that state update internally. So we need to expose some information to be able to verify that behavior, because it's only internal to the object. Probably not nice, but works. And on its own, it's not a problem yet. Then we have exceptions. Can be treated as another form of output. PHP unit offers you a nice way to test exception. We just state our expectation, we expect the exception to be thrown, and then invoke the function that is supposed to throw that exception. Nothing complicated. But getting more complex, we're getting to I/O, database, file system, external API calls. Whenever we communicate with the external world, we either reading from or writing to that world. Yeah? So now there's no excuse to test such a behavior. We actually need to talk to external world. There's no way to replace that world. So if it's a database we're talking to, we need to set it up. We need to write some data to it so that we can read from it. There's no other way to test it. we need to call that database. That means we probably need to create some schema, drop it first so that we start with the clean state that's predictable. This is an example using Doctrine Entity Manager, so we use Entity Manager to persist some data into it, and then we are ready to actually write the test to probably read some data or write some data to the database. Yeah? One thing we can do is to try to make that behavior that talks to the database as simple as possible. So extract as much logic to other collaborators, to other functions, methods, objects as possible, so that the part that talks to the database is as dumb as it can be. It doesn't have any logic, or at least no business logic. So there's less tests we need to write for it, because they will be slow compared to your other tests. And notice that extracted behavior is, again, a form of input or form of output. We just need to call a function to get it. Or we need to call a function to put it somewhere, to notify some other object about the result. That's what we call indirect input and indirect output. Right, so one more thing before we move on to doubles. Notice that the application is a set of your behaviors that are either composed or just called from each other. Yeah? So it can be thought of a big tree of behaviors. At the top is where your user comes in and what they see as a result. We can test such applications on multiple levels, right? Because we can test a single function or single class, single method in isolation, or we could decide to test stacks of behavior, bigger chunks. We can decide to test the whole app through its user interface or through the API. Yeah? I'm already going to tell you that's not the way, and I'm just going to refer to J.B. Rensberger, his talk, Integrated Tests Are a Scam. Really good, eye-opening thing if you never watched it. Basically, testing on the highest level or end-to-end leads to the need to create more of those tests. Those tests are slow, so it just drives itself and also has a big impact on the design. You stop caring about quality of the code you create, and your test suite runtimes only take longer and longer. So if all of those functions, behaviors we have in the application were pure, so they would have no side effects, they would talk no to the database, no to the file system, and all those other external world services, then it wouldn't matter on which level we are actually testing it. We would be free to choose. Problems start when we introduce state databases, exceptions. Because mutable state on its own is not a problem. Shared mutable state is. If we access that X from one place and it's not shared with anyone else, I can, in my head, reason about it, calculate it, okay, it's 4, and then I can jump up the stack and rely on that number being 4. But if the state is mutable and shared, I have no guarantees that by the end of my execution that X will still be 4, because some other part of the application might have called my object and changed the state. Yeah? Exceptions. Sometimes we might not be aware that something down the stack is actually calling an exception even. That's problematic because that exception can jump out back to the user if we don't catch it, right? So that's like a go-to statement. Exceptions are part of your result, but they are not documented. They're not part of the return type. You can't guarantee it's handled. Yeah, so there are problems with that. And I/O has all kinds of issues connected with the state and exceptions that everything that calls something that talks to the I/O is kind of tainted. It's also not pure, so it's harder to reason, harder to test, and harder to maintain. Yeah? So we can divide all these behaviors in 3 groups. Data, there's actually no behavior. We don't need to test data because they don't expose any behavior. Calculations, those are pure functions, so they are predictable, nicely tested. Yeah. Actions is where the dragons live, so everything is hard in there. We should limit actions, amount of code we have in actions as much as possible, and actually try to convert or extract as much calculations of actions to calculations, and then we can also try to make some of our calculations actually data, so we don't have to test it. Yeah. So there are application architectures that talk about it, like functional core, imperative share, where we focus all our pure behaviors in the center, so our domain model is actually pure and immutable, and then push all the bad, dirty things outside to the edges of our application. Yeah. I try to draw it on not really hexagonal architecture, there's no hexagonal, but you can call it onion. All of those are different views of the same kind of patterns. So we try to push all those dirty things to the edges of the application so that what's left inside is the most important, because that's business logic, but also that's easiest to write tests for. So how do we actually approach testing such an application? We test the chain of calls by testing each link. So what I mean by that? Let's take a specific example that we work with during this talk. That's a solution to code kata that I found somewhere on the net that is, or it is part of the solution. The kata is to generate unusual spending based on your payments history. Unusual spending report, I mean, so that when your current month's or chosen month's spending is somehow different to the last month's spending in the given category, it should generate you a report, send an email or a text, whatever. So what we have here is at the top is our use case, so that you can treat it like a controller. The usual spending use case that has an execute method with the criteria. Criteria is going to be how we decide for whom and for what period to generate that report. And it talks to 2 other objects. Unusual spending sensors, that's meant to detect that unusual spending, and the notification channel that would be called when the spending is detected violates the threshold or whatever. Yeah. The sensor also calls the payment repository that calls the database. The repository is used as a data access layer, I guess, to fetch entries from the database. This is like a solution that after a few iterations. So initially, I might have just probably come up with 2 collaborators of the use case. But then writing tests for the use case, especially the part accessing the database and detecting the unusual spending, was too complex, so my test doubles told me to extract 1 other collaborator. So that's the often pattern that you'll see in here. Right, so starting at the top, unusual spending use case, we try to detach from the implementation details. Actually, when I just started, I didn't have those collaborators yet. So I probably introduced interfaces for them. And they're like slots that you can put things in. Interface can have multiple implementations, so you can substitute those slots that you with multiple or many different implementations. So what my test exercises is the use case, but its collaborators will be replaced with objects that are suitable for tests. The spending sensor will get a stub. So a stub can be pre-programmed with answers to questions. If I call that stub, it's going to return 42. Yeah. Mock, so stub is for indirect input, for whatever I need in my object I'm working with. Mocks are for indirect output. So they don't necessarily have a result, but it's important that we call them. It's important that my notification channel is called because that sends the email. But I don't necessarily care what it returns, and very often it doesn't return anything. So that's for indirect output, yeah? So writing the test, I go down level, and now it's time to take care of the next object, the spending sensor. That depends on the repository. Again, I don't want in my test that repository to slow me down. I don't want to all the hassle with setting up the database. I'm focusing on the behavior of my spending sensor. So I will stop that repository find by method. Yeah. And it provided in the test instead of the actual implementation. What happens at the bottom there is that's where I stopped mocking. Because I actually need to make that call to the database to make sure that my repository does what I think it does. Yeah? So this isn't going to be a test that uses stubs or mocks. This is going to be the test that actually bootstraps the database, calls it, and verifies the results. Same on the right side, the notification channel. I actually need to, if it sends an email, I actually need to send that email to verify the behavior. Yeah? And there are tools to obviously catch that email, and doesn't really have to go to your clients. It shouldn't, but it should actually use some email infrastructure to send it, or make that API call, or persist something in the database. I don't want you to think that it's always one test per class, because it kind of looks like it on this simple example. But very often you'll have clusters of objects that you test together. Yeah? It's up to you, as Jipo said, to break the dependency chain the way you wish. So you decide how big of that behavior you want to test at once. Yeah? It doesn't have to be one. If you take a model example and DDD aggregate, for example, aggregate root is something that is composed of other entities, right? But we always invoke the behavior on the root, not on those entities inside. So we won't be testing entities on its own, but we'll be testing them together as a single aggregate, as an example. So those tests that use test doubles, I call them collaboration tests after JBrains. And we have 4 to 5 of them. Dummy object is with the indicator with dashed line, because it's not necessary. It's not really a test double because it doesn't expose any behavior. Test dummy is dummy object is just there to satisfy a list of arguments that you might have, and is then passed somewhere else to the other collaborator. It's actually not invoked during this test, but we just need it to pass it as one of the arguments. It doesn't expose behavior, that's why it's not necessarily a test double. Then we have 2 types of doubles. One focused on input, the other focused on the output. Test stub is focused on the input. It allows us to pre-program outcomes of a call to a collaborator. Test spy and mock objects are for the indirect output. They let us to track what calls were made, because we care about that database safe method to be called, because we want that record to be persisted. Yeah? Fake objects are both, because they are actually simple implementations of the real thing. So if you don't do test-driven development, you probably want to just work with fake objects. Fake objects example might be an in-memory repository that stores everything inside of an array internally. Yeah? So it is an implementation that works, looks like the real thing, but it's not production ready. So starting with indirect input, that's some behavior that we need to invoke to get that input into our behavior that we're testing. So usually it's modeled as an interface, so that slot that we can put various things in. In production, we'll put the actual real thing in. In the test, we will put a fake behavior that we can control. Yeah. So an example of a stub. I didn't mention that all the test doubles can be either handcrafted or we can use mocking frameworks like the built-in PHP mocking framework to create them. I'll show you both ways, let you decide what you think works better for you. This is a repository stub for the payment repository that's handcrafted. I use the feature to implement an anonymous class inline just to return an empty list, because that's what my test requires. Returns no usual spending if no payments were made. No payments were made, just returns the empty thing. So technically, I should also verify if the criteria is what I expect it to be, so that call, I'm sure that call was made with the criteria I wanted it to be called with. Yeah? But it would take more space, so I didn't include it here. There's a few things we could do to improve this test. Once I've written it, I realized the criteria is actually irrelevant to this test case, because it doesn't matter for what user or what month of year that behavior is invoked for, because that criteria is only passed to its collaborators. It's never actually used by the object I'm testing. So it kind of obfuscates the test here. I don't need that data to be included, so it's best to just hide it behind a method. Any criteria will do. So try to give it an intention revealing name. And this could actually be, I created real objects here. This could be a dummy, because it's never called, yeah? But I tend to not to mock data. You wouldn't mock number 42, the same way you won't mock something that's just data. Yeah? I could improve this as well by extracting it, give it an intention revealing name. Given no payments, I would expect repository that always responds with no payments. Now I can reuse it. Yeah? So the test becomes rather simple and states my expectations from the subject of the test very clearly. That was the handcrafted stub, still visible at the top. Down here we have the same stub created with the PHP unit built-in mocking framework. So we use the create stub method to kind of create an implementation of that interface on the fly, out of the thin air, and configure it. So say the method findBy will always return an empty list. Yeah? These are equivalent, they do exactly the same thing. This kind of approach was really popularized by the TDD, London School TDD guys who just wanted to have easy and quick way to create those stubs, because it's a bit less of work. There's a question whether you understand the top example better or the bottom example better, so I guess it depends on your team experience, and also the language you're working with. Because some languages make it easier, some languages make it harder to create such handcrafted test doubles. Another example of a stub, second test case, no unusual spending, but some payments were there in the repository, so we configured that repository stub to return payments, but this time I included the criteria verification, because technically that's what should happen. I should be certain what criteria was passed in there, and throw an exception otherwise so that the test could fail if the criteria is not what expected. So you see that there might be some code, boilerplate, just a lot. I don't know what happened here. Compare it with AutoMocker. If you can understand this syntax, it's a bit less to write and maybe even understand. This time we specify the find by method with arguments, with criteria argument as well. So that's equivalent to the example for the handcrafted mock, the stub. I should mention that there are other mocking stubbing frameworks out there. There's Prophecy coming from PHP spec. There's Mockery. You don't necessarily need to use the one built in into PHP unit. Just for completeness, another test, I just set up even more data, but still that repository is stubbed. I reuse the same method given payments. So that's the one you saw on the previous slide. If I had to put all this in the database, you know, imagine I have many such cases. I don't have to hit the database in this test. And this test deals with looking into those payments, gathering the report. So there's quite a lot of logic involved to make that calculation. I will probably need a lot of tests to cover it, this logic. With test doubles, I don't have to call the database. Second group of test doubles, dealing with indirect output. Story here is very similar. We have a bit of behavior that we want to, I'd say, send a message to, alert, notify with our findings. Yeah. So we will have some sort of interface as well, a slot that we can put either the actual implementation or our fake behavior, so that we can control it in our tests. So an example, here we can have a spy or a mock for this use case. So starting with a spy, we now move to the notification sending. Yeah, so we expect that that object publishes unusual spending notifications. Yeah. Construct some criteria, non-empty unusual spending, so you see what kind of spending that, you know, the name tells you what kind of spending is created. Given sensor creates the stub, so we looked at stubs before, that will respond to criteria with the spending. And we create the notification channel, that's our spy. Spy tracks all the invocations. So it remembers all the method calls that were made to it. So that later, at the bottom of the test, we can inspect it and we can assert on what was published. That's a handcrafted spy. I don't have an example of mocking framework spy because PHP unit does not support them, which is a shame. PHP spec does with Prophecy, but the built-in PHP unit framework does not. How it would look like with a mock object. First with auto-mocking framework. We expect that the method was called at least once now, yeah? With certain arguments. Notice we are not specifying any return values here because they're not relevant, but mock could be also a stub if it returns something. So we have an option to specify return value as well. We did not have that expects call in the stub because it doesn't matter how many times you actually call a stub, if you call it at all. That's not important for the stub. If you call it, yeah, that's the data. If not, we don't want to couple ourselves too much to the implementation. Yeah? If we over-specify, that couples us to the actual implementation. With the mock, yeah, we need to tell, that's the purpose. We need to make sure that that method call was made. And that's how we do it with AutoMocker. If you wanted to handcraft a mock, I think you'd be better off with a spy. It's simpler to do and it's easier to understand. Because notice, there's no assertions here at the bottom, yeah? We stated our expectations before we made the call, and that mock took care of performing assertions internally after the test has finished. So if you handcraft that mock, yeah, you need to, when the method call is called, method is called on the object, you need to verify if arguments are what you expect them to be, but also you need to track if that call was made at all, because at the end you'll have to make that verification, because if it wasn't called, that exception is never thrown, yeah? So we need to track those calls anyway. So stubs are a bit easier to implement this from this perspective. We can have, obviously, our expectations. We also can expect, okay, that unusual spending was not discovered, so we expect to never publish a notification message in such a scenario. Yeah, so we can use expects never instead of once in here. So that's a mock object. I don't really have an example of a fake, because a fake is just an implementation you write every day. It's just simpler than the actual. So Neil challenged me to put this on the slide. I prefer to write my own doubles in modern languages. I'll leave it up to you to decide whether PHP is a modern language or not. We have time? Okay. So you might think I was stubbing and mocking all those collaborators in my tests. But how do I actually know if I call that repository method findBy that it returns anything? Yeah? How do I know? I never called that database in my collaboration test. Yeah? So contract tests are a way to solve that problem. Having a bit of behavior that deals with infrastructure. In our other behaviors, we depended on the contract. So we depended on that repository interface instead of the actual doctrine database implementation. Yeah? So that's just short. And obviously, we have the doctrine implementation somewhere that we can put in our production code. But we also have that fake behavior that we made some assumptions about that we use in our collaboration tests that I've shown you before. Yeah? So these are the collaboration tests using those fakes. So now, how do we know that fake behaviors and actual behaviors implement the same contract, that they behave? I'm not talking about just interface implementation, because the types are there, the types match. You implemented that interface. But I'm talking about behavior that cannot be described on the interface. Okay? Whenever I call that repository method with a criteria, doesn't return what I expected to return. Yeah? So this is what contract tests are for. Yeah? How do I find test cases for the contract tests? Well, I can start by looking at my collaboration tests. This is the test we looked at before. And based on them, define test cases for my contract tests. Yeah? So when I said given no payments, I need to have at least one contract test that constructs the query in a way that returns no payments. I defined two. I defined one for when the user is not found, and one for when the date doesn't match. Yeah? And two other cases I defined for the case when the payments are found. So I need a test in my contract test that actually populates the database, calls it, and makes sure that the query returns results. Yeah? So the first of them, I use a bit of custom-made code to bootstrap doctrine, so to actually gather all the metadata, create the schema, drop it first, create it, and expose the entity manager to me. Yeah? Because this test will need to hit the database. Helper methods to hide what's irrelevant. So creating a payment is quite unreadable. I need to create lots of objects. And also not all the, there's a typo on this slide. These two should have default values. They don't. I want to leave in the test case what's relevant. What's relevant of this case? It's called returns empty list if no payments were found for the user. So I at least need to have user ID and the date to match the data to expected outcome. But amount and category, all that is irrelevant to the test, so I put it outside. And then given payments will actually go to the entity manager and persist everything into the database. I'm working with the database now. So that when I call findBy method for the criteria, you see that's user 2 There's no user2 in this data set I prepared, but there might be dates that cover the criteria, but the user doesn't match, okay? So I expect no payments. Second case I might write is for when the user matches, but the month doesn't match. Yeah. Again, setups of data, put it into database, query, okay. And also some case for when data is found, so I probably will need more than one case for it, but still, you get the idea. Yeah. Now, I actually assert whether the payments returned are free of those that I set up and I set up for. So not everything is returned, only that data that matches the criteria. This isn't a contract test yet, because it talks about implementation. So now to convert it to a contract test, we need to extract anything that's implementation dependent. We already have given payments extracted. That deals with the Doctrine Entity Manager. Now we create the specific implementation here, so let's just move it out. And we do that so we could create a base test case for that contract. Yeah? So we inject a new test case in between our PHP unit test case and our test case, and push everything that's implementation agnostic to that test case. So all the test cases, all the test class methods are there. Payment is there because it just creates an object. It's not dealing with database. But given payments, create payment repository, these deal with the specific implementations, so they were abstract and put into the actual test case. So our test case now looks like this. It extends the contract test and just sets up the instance to be tested and provides a given payments method so it can be populated. This gives us power to now create a new test case, like for the in-memory repository, that will pass the same tests. You could think you could have a file-based repository, or maybe something that doesn't use Doctrine. Such a test case can then be used, for example, in your, not test case, such an implementation of a repository can be used as a lightweight replacement in your acceptance test, for example. So they are equivalent because they meet the same contract. So they are replaceable. They are interchangeable around all the same tests against those two implementations, so that I don't have to worry that my acceptance tests don't run against the database, because my database meets the same contract as my file-based implementation. Yeah. So what we've done here is we had our collaboration test. Based on the contract, also wrote the contract tests. But notice that my repository can be used in more than one collaboration test. Usually you reuse that repository object in other use cases, yeah? So you'll have many more fast collaboration tests that do not hit your database than contract tests that actually hit your database. You test it once in one place. You prove that your test doubles work as the implementation of those test doubles, so that you can rely on your test doubles in the collaboration test. You don't have to actually hit the database, if that makes sense. Yeah, the Elmo should be here. Sorry. Let's look at some, and I'm not judging, I'm not blaming anyone. I'm not showing you the projects where this comes from. Also, you might not see every little line of code here. It's not that important. It's important that these tests are not really that readable. So one thing to notice about this test I found on the internet is, well, the method is not really revealing the intent of the test. So it says, test normalized minified search. And the method we are invoking that is being tested is called normalized minified search. So at the beginning already, the out of the test didn't give me a chance to understand what it's about. And stubs or mocks created here don't help. You see, there's a lot of orchestration. We need to create that object, and that object is passed to that object. And if you find yourself orchestrating those objects that you need to return this from here, there, you probably tests are trying to tell you that something is wrong with design, or your approach to the test is wrong. Because what happens actually here is we are mocking values. So just create it, it's going to be more readable, and the mocks don't give you any value here. Same here, continue orchestration. If this method get is called with Solar, just return this. It's some kind of a registry. Just create that registry. It's a map. And you see the test is disproportionately more complex than the code it's testing. The code on the right is 2 methods, single line methods, and there's so much code to test it. If you find yourself doing that, something is probably not right. And actually, I tried to understand what's being tested here, and I couldn't understand it. I don't know what it's testing. Calls the normalized minified search method and expects results to be returned that we set up variable. More mocking. In here we have some specialized mocks that invoke search and show methods on the collaborator, but explain or enforce how many times that the collaborator was called. So it says this once. Both collaborators need to be called. But these are stubs. They return values. So if we specify how many times those stubs were called, we kind of couple ourselves more to the implementation. So it's harder to evolve the design this way. So we shouldn't do it. Here we specify that the call to start was exactly twice. Yeah. If we find ourselves that we, again, assert a number of calls, or the order of calls, we again orchestrating those objects. That's like some other object screaming to get out of there. Probably some collaborator that would encapsulate all those calls, and we just call it once. Tell, don't ask. Yeah. So all that complexity around mocks, if you find yourself writing more and more complex mocks, they're trying to tell you that something is wrong with your design. And you should maybe think how to improve it so your calls are simpler. Lots of results assessing, and it's like things here like finding a certain, there's 20 elements in the array. We verify some random data and verify elements number 19 and 54. Why are they relevant? Why are we doing this? The test name again says test search, doesn't tell me what we are actually testing here. Yeah? So all those assertions, maybe it would help if they were hidden behind a custom assertion that had intention revealing name. Yeah? In here, pure value mocking. Yeah, we create a mock of column interface and specify get name and 2 string calls. Just create that column. Is it too complex? Okay. Use a factory, or maybe that object is too big. Again, feedback on design. Yeah? But don't mock values. Tests develop I think that method name is messed up. Yeah, but what we expect here is that method get debug was called once. Get suggests a getter, so it shouldn't have side effects, so it's unimportant if we called it or not. Yeah, so we shouldn't use once, because there's no output or indirect output that we want to trigger with this debug. Yeah? This evidently someone is testing the implementation. If this get debug was set to true, well, it prints some data, but it actually doesn't test the debug functionality, even though it says in the method name test debug. It just tests if the collaborator was called. And finally, this says should allow mocking protected methods. If you find yourself mocking protected or private methods, then that's again some collaborator that screams to get out, some object that screams to get out. That thing is doing too much. Yeah? And actually, those examples of stubs and mock I've shown you earlier, it's all you need to do stubbing and mocking. The mocking frameworks will come with various features like mocking private and protected methods. All those are edge cases that you hardly ever need. If you think you need it, think how to change your design so that you don't need it. Yeah? It's simple. Stubs, return values for the given output. We don't care if they call or not. They're there to serve us the value. Mocks, they're important if they're called because they have side effects. So they trigger side effects. They put something in the database, make a that notification call. So it's important that we verify if they call or not. Anything else that mocking frameworks provide you? Edge cases, think twice before using them. And finally, a lot of code. This is an HTTP client that mocks HTTP requests. So the only way to test the HTTP client is to make HTTP requests. It deals with infrastructure. It should call that infrastructure. You can set up a service that stands up before your test. You know what responses it generates. Make those calls, assert on the behavior of your HTTP client. But then only your HTTP client will be actually making those calls. Whenever else, you can rely on the interface that HTTP client provides and stub mock them. As long as it's your interface. We don't mock other people's interfaces. Thank you. So to summarize, verify the behavior, not implementations. Do not couple your tests to the implementations. That's the common thing people say about test doubles, that they couple your test to implementation, but just right, they won't do that too much. Mock roles, not objects. Yeah, mock those behaviors. I want to mock that function that makes the call to the database, not the whole repository. I don't think about it as a whole repository. I think about repository as the set of those behaviors it provides, and I want to mock those. Listen to your tests, let them guide your design. So whenever something is hard to write, whenever something is not readable, think how to change either your code or your test. Your tests need to be refactorized as well. They need to be readable and maintainable. Keep your tests as tidy as the code base. That was. And finally, I think test doubles, and mostly those auto-mocking frameworks doubles, are mainly a tool for TDD. If you're not doing TDD, you'll be fine with just using fakes. And that's it. Do you have any questions?
Yes.
If you don't want to ask the question now, you'll find me in the closest pub after the talk.
Thank you, Jakub. This was really great. And somebody even mentioned on Slack they love your slides.
Okay, thank you.
So, and then there's also a question here. Question to Jakub. Have you found using anonymous classes over mocking framework functionality makes tests more resilient to changes in the software version or third-party code, i.e. the mocking frameworks? Or have you found it hasn't made much difference?
Yeah, I'm trying to find the changes part in the software version or third-party code. I don't think it impacts the third-party code because we won't be mocking third-party code. We just need to integrate with it, actually call it. It's just two ways of doing the same thing. They will require slightly different practices to keep them tidy, but you can accomplish the same things, I think. So I've pasted that screen from Slack, which was the response to Neil, saying that I prefer to use handcrafted test doubles if the language is right. And have a look at how it looks like in other languages, because in languages like Java or Kotlin, for example, instead of an interface implementation, you can actually inject a function. If the interface only has one method, you can actually inject a function. That's the shortest stub you can write. Inline function, one-liner, returns 42. Yeah? And you can inject it as implemented. So there's no less boilerplate code you need to write to create that stub. So it encourages me to use language features rather than mocking frameworks. That makes sense. In PHP, depends on the team, I think. Because as an experienced TDDer, I really like mocking frameworks because they don't slow me down. They don't stop me. I still need to maintain those tests, make them readable, but that still doesn't interrupt my flow as much as going there and writing that anonymous class. Not sure if that answers the question, but hope it does. If not, then ask again.
Catch him. Anyone else? Question? So, yeah? Good.
Thank you for the talk. That's very good. With the tests that test like an API or test a database directly that you showed there, when do you run those tests? Do you run them as part of pipelines? Do you run them on deploy, or do you keep them just separate for like local development?
I run them together with other tests as long as I can. That depends on the size of your project. At some point it might not be. Very often I configure my IDE to only run unit tests or those true developer tests without infrastructure, so that I get quick feedback on while I'm working. But then, on commit I run all of them. But again, for as long as I can, I run all of them all the time. But at some point it will stop being viable or practical because the run takes too long. Yeah, makes sense.
Anyone else? Right, good.
Run.
Let me go to the magic door already. Yeah.
Hi. Really great talk. Really interesting to see kind of like some really good examples there. How would you go about testing methods which essentially kind of verify behavior, so more kind of like expectation methods, to test that they don't throw exceptions? Because that's something I do sometimes struggle with when I'm writing unit tests. So example...
They don't throw exceptions.
Exactly, like validation methods, for example, to say like, I'm going to validate all of these things and make sure that it doesn't throw an exception.
So I assume you have a state that is updated. I would need an example to understand the question better.
Say, for example, you're validating an email address.
Okay.
And you have a method that validates email address and throws an exception if it's invalid, but doesn't do anything if it's valid.
So what does it do when it's valid?
I guess it would be called by something else, wouldn't it? But
so these days, I would always return the value. So the validation method would actually return the validated object or an error.
Right, I see, yeah.
But if you use exceptions, I guess you could follow the same pattern. Either, expect the value that was validated to be returned, or exception to be thrown if it's not valid, if that makes sense, yeah? But I try to have that value back.
That makes sense, thank you.
Yeah.
Yeah, thank you, Jakub.
No worries.
It's time now, actually. We have
so you have more questions, find me afterwards.
Find him around, give him another round of applause, please.
Thank you.
And